Hello, I'm Paul. I'm a data scientist, but I'm doing data visualization just to communicate my numbers through visual images. And generally, I've got the same question, why we are visualizing the data. It's basically what the data visualization is good for. So I was thinking about this. I didn't come out with 10 reasons. Actually, I didn't come out with any good answers. I was just started thinking, we've got lots of data. We've got lots of tools. There is a really wealth of tools which we can communicate our data to the customers, to the people. But it's very easy to get lost in all these tools and basically get overwhelmed. So I think the better question is actually for whom we want to communicate this data. And obviously, we are communicating this data to other people. So data visualization is all about visual stimuli for other people. But if we think how other people see, it's not really, we don't really see very much using only our eyeballs. Our eyeballs, they are just sets of quite bad cameras. If you think what is the output of your eye, it's pretty much this. Sorry, it's actually not this. It's this, upside down, with big blind spot in the middle, pretty much blurry, and a small area of high resolution just above the blind spot. So clearly, we are not trying to communicate the data only through our eyes. Obviously, we are trying to target this organ. This is brain, and particularly the visual cortex. This organ is just putting together all the patterns which we are trying to communicate and turn this into some kind of information. And if we think what we are good in spotting, obviously the numbers on left are not very appealing, but tree on right, we are much better in spotting the red apples. It's basically the pattern in this tree than any pattern in these numbers. So let's look at the simplest data visualization as it can be. So it's just a line graph. So if you are looking for patterns, you probably quickly notice that this is the pattern on this data representing days. So this is the data which shows the traffic, the content about current election of the Mayor of London in 2012, which will happen in the next few weeks. And we can see it's a Boris Johnson versus Ken Livingstone, and we can see straight away that there is a pattern between day and night. So the content is rising during the day and it's pretty much down at night. And if you look at the dates on these graphs, you probably spot the numbers after you spot the pattern. The data is from May. Originally, the data was from last 2 weeks. I made a mistake. I forget that JavaScript counts the months from the month 0. For some reason, we are not providing data from the future yet. But generally, I wanted to illustrate that the pattern you can spot much quicker than the numbers or the symbols. And obviously, if we've got only 2 things to plot, you can use the line graph. But if we are trying to plot other candidates, it's becoming a bit messy. So what we can do if we want to plot more things, and this is the same data set. These are the links which people were sharing when we're talking about the current election of the Mayor of London. And if we look at the links which people were sharing, should be here. Let's try to run this. So this is how the links were shared during the time. So we can, using this graph, we can communicate 4 variables plus time. So the y-axis tells us about the social resonance, so it's basically how many people shared a certain link. The x-axis shows us the social reach, so how many people could be exposed for this potential link is basically, this is aggregated number of all followers of all people who shared the link. The color represents the sentiment of the comments which were in the tweets which contained the link, and the size of each dot represents the cloud score of the average cloud score of all the people who shared this link. So we can see that this link, for example, starts with very small cloud score, and it's basically being shared by many people with lots of followers. This is one of the ways to communicate data which has got more dimensions than 2, and over time so let's look at another example. This is the piece of financial data. This was the moment when Research in Motion CEOs resigned on one Sunday afternoon. I mean, they communicated this on Sunday afternoon, and we were looking what was happening on the social media. So there is obviously a massive negative spike on the moment when this data was communicated, when this news was communicated. And we were looking at what was happening in the social media. So this is the graph of all people which were talking about RIM when hour before the news was communicated. That was the moment when the news broke, and this is the traffic which happening after the news was communicated. But we can do this in different way. We can do this using the same data, but we can play it with time, so we can see what's happening. This is when the news is being communicated, and now people are talking about this news. There is the middle of the night now, but in the morning people are still talking about this news, and the traffic should slow down a little bit. So in this way we can see more patterns. They are mostly temporal patterns in the data, but it tells us actually what was happening. That was some event, something happened, people were engaged in this, people were talking about this, and after that the traffic pretty much slowed down. So this is the one way of communicating this visually. That is another way. If we look and focus on patterns only, we can play it like this. So the colors are positive or negative news communicated. Gray colors are this is the neutral content. This is the same data set about RIM CEOs resigning. And this is the same set, but we are using a slightly different algorithm to illustrate this over time. Is it still going? Yeah, it's still going. Yeah, this is the next day after. And one more thing I wanted to show, it's also one of the network graphs, a bit of a background. That was the news when Facebook was announcing that it's going on the stock market with the company, and the big spike, obviously, this is the moment where Mark Zuckerberg announced the letter to the potential investors. So we were looking what was happening around this time. And obviously, Facebook has got much more coverage on social media than the Research in Motion. But so this is the traffic which was happening before he announced the official news. And now, when the news was announced, the traffic is increasing significantly. And you can see that the biggest dots, the biggest labels are basically the news outlets, the news organizations which are breaking the news. And this is it. I'll be very happy to take your questions afterwards.